Hi, and welcome back to the Low Level Devil channel's OS development using the Linux kernel series. In the previous video we started setting up our DRM KMS library and created an application to display the different video modes available. And if you haven't watched the previous video, you'll really want to watch it first. There's a link to it in the description. In this video we're going to continue with using the DRM KMS by setting the display mode, setting the screen background color, and drawing a box where the mouse pointer should be. So let's get started. So we'll start by going into our DRM header file and adding a couple of functions. The first one is going to be my DRM underscore get underscore encoder. So this will give us an encoder. We pass in the file descriptor, the ID, the DRM mode get encoder structure. And we can see this structure here in the Linux kernel header. The next one we're going to want to add is another extern int my DRM handle event. File descriptor, and this time we're going to pass in a struct my DRM event context. And context. And this one of course doesn't exist yet, so we're going to have to create it. So we'll go up here and add it. So it's going to first have an int version, and then it's going to contain two different function pointers. The vblank handler, this takes a file descriptor, uint32 sequence, tvsec, tvusec, and a void pointer for user data. And we won't actually use that one, but we will use this one, the pageflip handler. This is what we're going to call when a page flip is done, so we can repaint. So this one again is going to take a sequence, the tvsec, uvsec. Let's put an underscore there. And void pointer user data. Okay. So now let's go and implement these functions. Start copying them, paste them down here at the bottom. Okay, remove extern. So we'll start with the DRM get encoder. First we're going to just clear out all the bytes in that object, in that structure pointer passed in. Alright. Okay. And now we want to set the encoder ID to the ID passed in. Now we're going to make the call to the ioctl mode get encoder. And this one's pretty simple, so all we really need to do is just return -1 if it failed and return 0 if it's successful. So now moving on to the my DRM handle event, this is what will get called when a paint event happens. Well, it's essentially what a paint event is, but not necessarily. So let's start with just a char buffer or 1K buffer. Struct DRM event E, and we can see what this is. It contains a type and a length. So essentially what we're going to do is read the DRM events. So let's say sys read on that file descriptor, the buffer, and size of buffer. So we might get more than one at a time, so we're just going to kind of read them in a big chunk, 1K of them at a time, or however many There is. So if len is less than the size of struct DRM event, then we know there was some issue, so we can just return -1. So now moving on, we're going to essentially say while I is less than len, we're going to grab DRM event pointer at the buffer at index I. So, and then we want to increase I by the size of DRM event, or E length actually, because the DRM events might be variable in size. So switching the type, there's only one type we actually care about, and that's the DRM event flip complete. So when a flip is complete, then we want to call that flip complete handler. So we're going to grab DRM event v blank v b. Let's see, cast that e, and now we want to invoke. So you can see that's got these different values here. So those are all the values we need to pass to that function. So if we call VB, that's not there. Actually, we'll call context page flip handler. Remember, this is our context here that's passed in. And then we'll pass in the file descriptor, and then this v blank, or we call it VB sequence, then tvsec, then tvusec, and user data. So that'll just invoke our page flip handler, and we're just going to simply return 0. So that pretty much does it for our MyDRM library. All the rest of the complicated stuff's going to kind of take place in our DRM list program. So let's start by adding a couple more headers up here. We're going to include fcntl.h. We need to add some structures as well. My DRM buff. So this is going to be our buffer object. We're going to have this uint32t width. It's going to have a height, stride, size, handle, then a uint8t pointer to our map. So this is going to be an actual byte pointer to the frame buffer, and then FB is the frame buffer ID. So now we have another DRM data structure that we're going to pass around. That's that user data object that you see as a void pointer in some of the APIs. So the first thing is going to have this file descriptor, and it's going to have two frame buffers, because we want to have a front frame buffer and a back frame buffer, so we can do the double buffering, as it's called, of the CRT ID, page flip pending, a cleanup flag. We'll have the front buffer that we're going to be using. Alright, we'll have a width and a height. And I think that's it for our data object. So now we're also going to have a mouse position info structure that's going to have an X and a Y, and we'll have a max X and a max Y as well. And we'll just create a little global mouse pause variable. Okay, so now moving on, we will create another struct here, DRM mode crtc, and we'll call this saved crtc, because when we change the CRT controller, we actually want to revert back to the original one at the end. So now we're going to predefine this function setmode, where we pass in the data object and then the mode get connector and our actual mode info. We'll just predefine that for now. And I'll paste it down here to get started. We actually won't get to it for a little while. There's a lot of other setup we need to do first. Starting with, in our main function, let's see, we'll go right down here. We want to add these two variables, hrez and vrez. So we want the user to be able to pass these on the command line. So if the arg count is 3, then we know they passed them. So we'll take the first one as the h resolution, convert that to an int, and the second one will be the v resolution. And we'll add a printf attempting to set res %d by %d. Right, yeah, hrez and vrez. Alright, next we're going to set a couple of fields on this data structure, but yeah, first we need to define it, I guess. Let's do it. We'll just do it right down here. Struct my DRM data. So we'll say data dot cleanup is false. Data dot pflip pending is false. Data dot front buffer, we can set that to 0 to start with. And a couple of the things we'll want to set up. Let's see. We'll do the hrez and vrez. So width equals hrez, height equals vrez. And going down here, see, we do our count connectors. So before that, let's do a syscalls DRM IOCTL set master 0. So that sets us as the DRM master. And at the end we should turn that off, which is a call to, let's see, DRM IOCTL. Let's see if I can remember what it's called. Let me just type master. Clear? No. Drop master, that's it. So DRM drop master. Alright, so now that we have our mode, we want to check to see if we actually found the mode that the user entered. So we'll say if the hrez is equal to the modes m.hdisplay and the vrez is equal to the modes m.vdisplay, that'll essentially mean we found the right resolution that they entered. So then we want to just return that setmode function. So we'll call return setmode and pass in the data value and the con. Remember at data because we're passing a pointer to it. Connection and the modes m. And this actually wouldn't be called because we're returning, so we'll save it here for later. Or actually we'll keep it there too, because if they don't set the mode, then we'll still want to drop master. Okay, so now before we actually go to set mode, there's a couple other functions that we'll need to create. First and foremost is the frame buffer. So we're going to create a function to create a frame buffer in DRM. That's one of these dumb buffers as they're called. So it starts with an fd and we pass in that mydrm buff object structure. So DRM mode create dumb crec, and we're going to create drec, and then DRM mode map dumb and be our mrec. These are just different request types we gotta invoke. We'll start by zeroing out the crec one. Set the width to our buff width. Set the height to our buff height. And there's a couple other, that's our BPP, actually, oops, I did that wrong. crec.bpp, that's the bits per pixel. It's 32. So now we'll call the ioctl fd drm ioctl mode create dumb and pass in the crec. So if for some reason that failed, then we would just return -1, return false actually, and we'll printf some stuff saying that that failed. Failed to create the buffer, and we'll return value. So if that passed, then we'll go on and we'll say the stride is equal to the crec.pitch. The size is equal to the crec.size. Let's see, the handle is equal to crec handle. What else do we have here? Struct DRM mode fbcmd. We're going to create a framebuffer command object. Mem0 that stuff out. fbcmd. Alright. So now we need to set some of the parameters on this framebuffer command. So we'll start with the, let's see, fbcmd dot width is the buffer width. fbcmd height is going to be the buffer height. And let's see, fbcmd dot depth is 24 colors, or not 24 colors, but 24-bit colors. And the bits per pixel is 32, which means we have that alpha bit, if you're not aware of that. The handle, we're setting to handle. And now we need to call the ioctl for DRM ioctl mode add fb. So this is where we're adding a frame buffer. And of course we need to make sure that returns the correct value. So we'll print out a message if that failed. Let's see, failed to add FB. If it's less than 0. Right. And we'll return false. So now we'll call buffer FB is equal to FB command FB ID. So we're setting the frame buffer ID. We'll do a memset on this M request. So this will be our map request object. We want to set its handle to the buffer handler. Buffer handle, that is. And now we're going to call the mydrm ioctl fd, and this is going to be drm ioctl underscore mode map dumb. So this is where we're mapping the dumb buffer. So we have a pointer to the address in memory for it. So of course if that returns some thing. Let's see, failed to map frame buffer, and we'll put in a error code for it. Return false. So now we want to actually call sysmmap. So this is where we're gonna use the memory map function. Read, write, and shared D, and then mrep offset. So if for some reason this map object returns the value -1, we'll need to cast it to int64t first. So if it returns -1, then we're going to printf failed to map fb. And we'll just, to return and then return false. So now we should have the pointer to the actual memory location. So let's just go ahead and clear it out. And setting that value to all zeros is essentially going to make the screen black, because it's essentially setting every one of the pixels to 0. So now we'll return true at the end. So now we have our function to create a frame buffer. Another function will create, actually let's create some variables here first. I'm going to have a little square for our cursor to start off with. We'll set its size to 20, and then the background color we're going to set to a gray color. And let's see, cursor color, we'll set that to a blue color. And now if you aren't sure what those values mean here, you can add a comment. So the first two, FF, that's the alpha channel. Then we have the R, G, and B. So FF 255 is the value for B. You can ignore the alpha channel for now, just set it all to FF for all your colors. And we'll have a variable for the left and right mouse button being down, because we'll use those to add some flair to our cursor. So let's create another function, draw underscore data. So that's going to take in our file descriptor and then our structure to our data object. And let's see, we'll start by casting it. Actually, we'll start by grabbing that buffer. So we'll grab the frame buffer, and we want to grab the current one, the front buffer, XORed with 1. What's going on here? Oh, I spelled that wrong. My DRM data. And it's not front buffer, it's, let's see, what do we call it? Front buff. Okay, so now int start x, so this is going to be the start x of our square that we're going to draw. Will be the mouse pause x and mouse pause y. And now we're going to create an int32 pointer. This is going to be our map buffer that's currently a byte pointer, so we want to convert that to a 32-bit so we can control it by pixel, because each pixel is one 32-bit value. So first we're going to mem set it to the background color, so that should color the whole screen to whatever we set BG color to. In our case it's gray. So clear the background. Now for int x equals 0, x is less than the cursor size, x plus plus, and then we'll do the same with y. So we're going to loop through the x and y for the cursor size. Now we want to calculate the position, because you remember this map is just one contiguous array of 32-bit values. So to get the value, we'll take the start x plus x, and then the start y plus y times the width. Hope that makes sense to you. Essentially, we're going to try to grab the single position by grabbing the X and Y offsets. So now if the position times 4, remember it's a 32-bit, so if it's greater than our buffer size, then let's just break, because we don't want to crash the program if we go over it. So we're not going to try to draw past the end of the buffer. And now let's create a color. It's going to be the cursor color, but if the left down flag is set, we're actually going to say color or equals that should be the red value. If right is down, color or equals 00, ff00 for the green value. So we'll add the green color if the right is down and the red color if left is down. So now we simply say p position equals color. That's just some simple square box drawing at a certain position. So I tried to keep it really simple. So let's go on to struct DRM mode crtc page flip. So this is a page flip command that we're going to want to make. So first we set the frame buffer ID to our buffer and .fb. crtc ID to the data crt ID. The user data we're going to set, we're going to cast it to uint64t, but it's essentially just going to be the address of our data object, which is already a pointer, I believe. Yep. Flags are going to be DRM page mode flip event. And reserved we'll set to 0. So now we're going to call the ioctl for this. It's DRM ioctl mode page flip, and pass in our flip variable. Let's see, and if not ret, then we know it succeeded. So we'll say page flip pending is true, and we'll change our front buffer. We'll XOR equal it. XOR equal it to 1. So that'll essentially swap our buffers. Otherwise, I guess we can print out some data saying that it failed if for some reason that call fails. Char C. Yeah, we'll just use printf. We don't need to use sprintf. So printf failed to flip, and we'll give the return value. And I think that's essentially it for our draw data function. Alright, so now we can go into, I think there's one more that we have to create, our page flip event function. So it takes an FD, let's see, uint32t frame, the sec and the usec, and then a user data. And the first thing we want to do is cast that data to our own data structure. Let's call it dev, it's for a device. So now dev pflip pending is false, and let's see if it's not in cleanup mode, then we're going to draw data. So whenever a page flip is requested, essentially you want to say, okay, draw the data, which will trigger another page flip. So now I think we can move on to our setmode function. So first of all, if there's no encoder ID, we'll just print out no encoder found. So we can't do much without an encoder. That essentially encodes it to be viewed on a monitor. And see, DRM mode get encoder. If you remember, we created that function in our mydrm library. So mydrm get encoder data fd conduit encoder ID and encoder. So if that fails, we'll just print out some more failure messages here. Alright, so now if there is no crtc ID, then there's no CRT controller, and that means we can't really do anything. So again, return -1. So now that's all out of the way, we can say data frame buffer 0 dot width equals the mode dot hdisplay. This is where we're going to actually create these frame buffers. So set the height to vdisplay, and we'll do that for frame buffer 1 as well. Okay, so now we want to set our mouse positions as well. So we'll initialize that to 0x and 0y, and we'll set our maximum values to these hdisplay and vdisplay. Okay, vdisplay. Alright, so now if not, create frame buffer, pass in our data fd and our data frame buffer 0, the address of it, that is. So if we fail to create the first buffer, we'll just print out an error, can't create the buffer, and we'll return a -1 for that too. And we'll do essentially the same thing for the second frame buffer. Frame buffer 1, and we'll just say frame buffer 1 and frame buffer 2. So now that we passed there, we know we've created our frame buffers successfully. I'm going to print out some of the details. Buffer created with size %d dot size. Okay, now I'll struct DRM mode crtc. Let's see, we'll memset to clear this. CRTC. And now we want to set the CRTC ID to encoder CRTC ID. So now we can invoke this CRTC ID. Yeah, first we want to set this to the encoder CRTC ID as well. So now we want to invoke the mydrm ioctl, drm ioctl mode get crtc. So now that we've gotten that CRTC, this is going to get the current one, which is essentially going to be the frame buffer. And when I say frame buffer, I'm talking the console frame buffer. So that we can set it back to that when we're done. And we'll set the saved CRT value to that. You can add more error handling here if you want, but I'm kind of just trying to breeze through this, so I'm not doing too much unnecessary code. Alright, so we'll print out some of the details. Let's see, this, the X, and the name. Alright, so we'll say, I guess we should put the return value in there as well. So crtc ID, the return value. Let's see the framebuffer ID. We'll see the count of connectors. We'll see the pointer to it. And we'll see the name of the mode. Okay. So that's just some informational stuff to print out. Let's see, it's all the right size. Okay. So now we'll mem set again, or mem underscore set. So we're going to clear it again. So that first one was just to get our previous frame buffer. Again, set its crtc IT to the encoder crtc ID. Let's see, mem copy. So now we want to copy the crtc mode, our mode object, into that. And then we'll say x is 0, y is 0. More details on what these are in the header if you want to look at the header for the Linux kernel for more info. So we'll grab the frame buffer ID for the very first one. Say count connectors as 1. And then we'll set that pointer to UAT64T. We'll just use the address of con.connector ID. And mode valid we need to set to 1. So now we have everything set up so that we can actually switch the mode. So we can go on here to int mousefd sysopen. So we want to grab dev/input/mice. You can also use the event API if you want to use that, but for now I'm just keeping it simple here to make the code smaller. And I'll print out the file descriptor for the mouse just to make sure you have it so you can see that it was actually there. And we'll print out some of this crtc resource information. What's the resolution size? So we'll say crtc mode.hdisplay and crtc mode.vdisplay. So we're essentially going to print out our mouse file descriptor, print out our resolution, sleep for a few seconds so we have time to see it before we set the actual mode. So about to set mode. So to set the mode, we're going to call my DRM IOCTL fd DRM IOCTL mode set CRTC. So that's setting the CRT controller. So now if that failed, we'll print out a failed message. Let's see. There isn't much we can do at that point. We'll just say ret and return ret. Alright, so now we'll just sleep 1 second. So you'll see the screen is black for 1 second, and now we're going to actually do our draw data. So pass in the data file descriptor. Data. So now we're setting up our main event loop. And if you remember on one of the previous videos we used select, sysselect. So we're going to use the same thing here with a fd set fds. Let's see, struct, no, let's do fd0. So we will zero out that file descriptor set. Okay, so struct my DRM event context ev. We're going to zero that out. say the version is 2, and the pageflip handler is our pageflip function. Let's see, pageflip event function. Alright. So now, while true, this is going to be our event loop. We'll do fd set 0, fd's, that's our input, keyboard input that is. Then we add the data fd, that's going to be our actual drawing, and then our mouse fd. So now we'll call syselect, and we'll do mousefd fd plus 1. If you don't remember how to use syselect, it's in one of the previous videos. I won't go into the details here, but it's the same as the select function in the standard C API. So if that fails, we'll just print out select failed. At that point, there's not too much we can do, so I think we'll just break out of the loop. And let's see, if fd is set 0, so if you type on the standard input, and then we're just going to break out of the loop. So essentially we'll just kind of do our loop until a user presses a key. So now if fd is set, so if our data file descriptor is set, that means that we're actually drawing some data. So drawing happened on the buffer. So we're just going to call our myDRM handle event, pass in our file descriptor and our EV object. And then finally for the mouse, I'm going to say if fd is set, let's see, if fd is set mousefd, and we know a mouse event happened. So this mouse event is actually a 3-byte buffer. So we'll do a sysread buffer 3 bytes. Now byte 1 is the X position. Byte 2 is the Y position. And byte 0 actually contains flags, so if the left button is down, the flag 1 is set. If the right button is down, the flag 2 is set. I believe flag 3, which would be and by 4, is the middle button, if I remember correctly. So and we'll do some bounds checking here. So if the mouse pause X is greater than mouse pause max X minus the cursor size, we don't want to go past the right of the screen, so I'll just set the value back to that max value. And then we'll do the same for Y. Let's see, Y. Okay, and now we can print, let's see, if R is greater than 0. Actually, we don't even need that check. If that's not true, then we're already broken at this point. So let's just printf, print out some details of the mouse movement. We'll say %d, %d, %d. So we'll print out each of the bytes. Buffer 0, buffer 1, buffer 2. You don't really need to do this because you'll actually see the mouse, but it's good for debugging purposes. And now at the very end, after we're finished our loop, we want to set the restore the previous CRT controller, because if we don't, then you won't go back to your text prompt. So in order to do this, let's see, They are saved crtc, count connectors is 1, save crtc, mode valid is 1, and then set our connectors pointer back to con dot connector ID. Let's see, and then again call this ioctl DRM ioctl mode set crtc and pass in our saved one. So this should return us back to our console frame buffer. And we'll close that file descriptor as well. Close our data FD. Drop master as well. So drop master and then close our FD. And we can say done. So let's see if this thing actually builds. So I'll open up terminal. And first we'll need to build the mydrm lib. Mydrm. Looks like there's a warning here. Take a look at it. And user data. Well, I think we just cast that. Yeah, we'll just cast that to void pointer. So we'll make sudo make install. So now we'll go to our DRM. Let's see, DRM list. Make. There is an error. Looks like I just spelled something wrong. My DRM ioctl. Not bad. One error for all that coding. Let's see. Make. Sudo make install. Okay, yeah, before proceeding, let's fix a couple things here. First, I'm going to comment out a couple of these to make it easier to read our output. We don't need to print out these connectors, and let's take that sleep out so it doesn't take so long. And one thing we missed, pretty important here, data.fd equals fd. Won't get very far without setting the file descriptor correctly. So let's make again and sudo make install. Now we should be able to reboot and try it out. So let's go with sudo reboot. Alright, pick my OS. Get our little splash screen here. So let's type DRM list, and that should list out all of our different modes. I see quite a bit of modes there. Let's just pick one of them. So we'll say DRM list, and we'll choose 1024 by 768. Alright, everything looks good. There's the mode changed, and there's our cursor with our screen. It looks like I didn't really do the bounds checking correctly. I did to the right, but not to the left, because it kind of loops to the screen there. But yeah, moving the cursor around, you'll see the mouse move. Let me try a different resolution. Let's see our DRM list, and we'll do, let's see, 1680 by 1050 will be a good one. That should fit in my screen here. Alright. So there we go, and there's our mouse cursor moving it around. The bounds work to the right and left. And, left click, right click, now left, and then right at the same time. So now it's white because both channels are added. So you can play around clicking your left and right arrows to change the colors. And there you have it. There's a good intro on using DRM and KMS to view the different modes you have and set different video modes, that is, and drawing the data on the screen, back buffering, page flipping, all that, and playing around with your mouse position. So I think that's a good enough intro for you to get started and come up with your own cool ideas for your own graphics library for your own Linux-based OS. So I hope this video was useful to you, and if you did enjoy it and you learned something, then like and comment and subscribe and join our subreddit as well. And thanks again for watching.